Yes, welcome. We'll be starting with a message from Jay regarding our values. Let me start screen share.
Shaman Kumar, Pradeep Balsubramanian. Awesome to meet everybody here. And so let's kick off. So what I'm going to do is, as usual, we have a guest session planned right now. And more importantly, we kick off with values. For those of you who have not attended my previous inner circle calls, I wanted to keep it a hybrid. So I'm going to be now talking about, what the community is about and what our vision is. So let me just bring that up. Share screen. Awesome. So our community is the vision. Let's start with the holy grail. So current upskilling and education techniques are broken. The more and more I've witnessed it, the more convinced I am about that. And the idea is to be able to get a fulfilling and lucrative career. It's not enough that you make money, you should also be fulfilled. So that's both are very, one is hard, both should be harder, right? So that's the idea. Hey, good to see you, Karan. And the mission is to be able to build the world's largest society or community of Web3 blockchain engineers and AI scientists or data scientists, as the case might be. And if tomorrow we add more and more courses, we're going to get that. And really, with high quality and high pedigree, right? As you might have seen now, blockchain is partnered with IIT Madras. The good news is also the IIT Madras AI has also been partnered. So, and I'll tell you more details as the week, as time progresses. Vision to be able to collectively empower every human. That is very, very audacious, but it's good to have audacious goals to live a fulfilling and lucrative career. That's pretty much the idea. Mahesh, yeah, hello. Venkat, Shravan, good evening. Now, next, what is our code of honor? First is remote. This is a remote first community. I know that offline events are now picking up because everybody wants to go out. 3 years they've been cooked in. However, we'll continue a remote first, and once the time progresses, we'll have maybe a hybrid model, right? Growth. Idea is to learn new tools, constantly be abreast techniques and master them. I'm not here for like some legacy tools. We're not here for like learning something and sort of being stagnant. The idea is we'll constantly upgrade and be at the best. So push ourselves to the cutting edge and go out and seek it ferociously. Clarity. I always push this again and again. Now, strategy, communication, marketing, extremely important. You must be able to sell yourselves. If you feel like, oh, I know coding, I'm such a smart guy, I have high IQ, companies will come to me. That's not happening. You have to push yourself. Pushing yourself means getting rejected 9 out of 10 times. If you can take spit 9 out of 10 times, you're pretty much okay, right? If not, that's really not good, right? So look at people like Elon Musk, etc. That push it. You have to keep constantly being outside. Efficiency, speed of implementation. I think it's self-explanatory in that we actually kick off, take action. A lot of results. There's a lot of noise. There's a lot of things. Don't be like now. Okay, let me push it for tomorrow or day after. You have to be able to, take quick action, right? Abundance. Be in this mindset that of collaboration, not of competition. Too often, I don't know, we've gotten from our school, etc., being the topper and or whatever, not showing the other people, ideas and all that. So make sure you collaborate. You can collaborate your way to like massive success, right? Look for synergies, look for cross pollinations. This itself is a very, very motivated and smart community. Leverage that, right? So that's abundance, right? More you give, the more you get. The more you give, the more you get. The minute you're asking, why am I not receiving? Why only me? You're gone. I swear to you, you're gone. If you're thinking, oh, why did this happen to me? Oh my God, why did this health issue? Or oh my God, why am I not getting best jobs? You're not giving enough. And that's why we've instituted the charity piece. Proud to say that we've crossed about 1 lakh in charity, both time and money. 5% of your time has to go back. We'll start measuring it. I know that up to, for some of the older members, we're going to have a form to measure that. 5% you should give back to charity every month. Like, be unemotional about money and just give it. And trust me, these things open up. You'll get it back. Okay, 1 second. So I'm going to be quickly just talking about, again, regurgitating the focus, right? So if you're if you're in the AI community, idea is to be first finish off bronze, then silver, then gold. Just keep the progression like that all the time, right? The most important thing is mindset. Broadly, the thesis is, at least I believe, I'm convinced about it, and my conviction is very deep, that unless you nourish your mind and soul, nothing is going to happen. And I get more than 800, 900 mails, and I can see that pattern recurringly. So my obsession is, how do I continue to make you reach for the stars? And this is the only way, right? If I teach you more coding, if you teach you more, it's not going to happen. It'd be like a bucket, and we keep with a hole and we keep pouring water. Have your goal card. Everybody who has their goal card written, one specific goal card, no deviations for that, for over a year. Every day, please write it. I've just been very proud that I finished my one goal card. I think I've shared it 2 weeks ago. Stick it everywhere. Go become insane, but in a systematic way, in a healthy way, right? It's okay, right? When sometimes, you have to like keeping the same goals again and again, right? I've always posted this. There's only one motivational thing that we're going to be doing. That's Earl Nightingale. How many of you have been listening to Earl Nightingale every day, twice, first thing and this thing, every day? Please type 2 in the chat box if you have been doing that. Or if you've done it at least once or twice, you just say that. Yeah, just listen to it every day. I've not missed a year and 2 months of it. Can you believe that? First thing, and now it's become basic, like it's brushing now. Probably I don't even brush sometimes in the evening. Now it's made it basic, right? The difficulty is making hard things basic. Hard things basic. Your mind, something magical is going to happen. Now, I'm not a psychiatrist, but it works. It just works. Just follow blindly. Surrender and follow to the systems blindly, right? Do I have your commitment that you're going to do the goal card, Earl Nightingale, affirmations? There's a lot more, but start with these small things. It's like push-ups and all for the physical health. For mental health also, you got to keep doing it, right? Do I have a 100% commitment? All of you guys, type 100 in the chat box right now, guys. 100%. You have to have all these hustles to constantly keep your mind at the forefront of everything, right? This is not a joke. This is not a whatever, some voodoo thing and all. Nothing. Simple. Brain is the most important thing. Nothing else. Your mind, your soul. Okay, cool. Then you start with the programming aspects. We have over 100, 200 hours of content, but none of that is useful unless you finish that. And declutter your entire inbox, declutter your entire all notifications, all emails, delete all apps. Only have 4 apps. We've said it in the webinar, we follow it. It's super easy to stalk your ex or something on Instagram, and that's not your fault, because they are supercomputers loaded with trillions of dollars mining your head and space. So please delete that. That's my sincere request. You can't embark on these cutting edge technologies unless you have a mindset. Decrease your footprint, decrease your online footprint, decrease your uninstall apps, all newspapers, like newsletters. That's all. Just unsubscribe to everything. At least for 100 days, you do it. 100 days, you'll be transformed. Okay, so then AI is fairly straightforward. These are the concepts that I covered. Just go in. We already have started. A lot of people are getting very, very good results. In fact, I have a surprise announcement as well. As a beta, how many of you want to know the surprise? Type S in the chat box. Okay, so for those of you so we are experimenting. I spoke with the team, and I think it's the logical next step. Since it's a year of building the community, we are going to test placements. I repeat, we're going to test placements. What does that mean? There's a specific process. We're going to be testing. I've already lined a list for both the AI and for blockchain, like set of recruiters, set of companies, but there are specific steps that you guys have to follow. Okay, and this is so that you guys get better jobs or promotions, whatever the case might be, right? And I'm very excited about it. Because I know some of the members have been reaching out to me, need that assistance. So I'm going to be doing that. I'll give me for some time. I have drafted an email and I'll be telling you the specific instructions. Those of you who've just joined 2 to 3 months ago, it's okay. It'll take some time. but some of the earlier members, etc., will be very, very beneficial. Okay. How many of you guys are excited with that? Type EXC. Excellent, excellent. So it's going to be first, we're going to start with like the gold, the live patches, then the silver, and then towards the end, maybe as time permits, the bronze, right? So it's going to be for increasing order of the seriousness. Okay, cool. And so after that, we cover, like I said, so finish these modules. I won't go to the depth today because we have a guest speaker. So I'll just summarize this. Complete these, Introduction to Python Programming. There are 4 modules within AI. Then the statistics, go only through that, right? Then the AI silver piece, many of you have accessed the linear algebra, linear models, applied modeling, and Kaggle challenge. Finish all of that. And then once you finish that, the gold program has not kicked in yet. When it kicks in, I'll just let you know. And please do reach out when your gold card or Hall of Fame and all these pieces have been achieved. I've given these specific mind maps as well for everybody, right? Keep simple goals. If you're a student, something like 10,000 or 20,000 rupees internship, you can get in either of these technologies. In fact, AI and blockchain, similar range. If you're a fresher, sub 10 lakhs is a good aim to start with. Don't have outlandish aims, etc. Go incremental. Little above market rate is fine. Figure out what your market rate is. So how to set a goal card, I would request you to watch the goal card lecture that I already have in one of the videos, right? Cool. Same thing for blockchain now. Let's go through the BLPs a little bit. So blockchain also have the same elements. I'm not going to repeat the mindset. Kashmir will cover some adjacent territory of that. So the modules 1, 2, 3, evolution of blockchain, hash, public hashing, etc. And then take the quiz. Then the module 4, 5 is the Bitcoin nodes, testnets, quiz, etc. All are MCQs neatly done, right? Finish that. For those of you who have already finished in the live sessions of the gold, great. And then the same for the blockchain finisher. So we won't go too technical in the interest of time. And the same thing for Hall of Fame or gold. And you can also tie your gold card once the placement beta is going to come in. The placement is a beta because I want to test it out. I know that we've never sort of talked about it too much. Okay, cool. So that's the traits are fairly self-explanatory, being self-reliant, being fixed on your goal, being extremely responsible. I see so many people who the hallmark of mediocrity is blaming others. Take responsibility, even me, myself included. Every time in life I've seen that, oh, because of my father, I lost my IIT Madras election. Oh, because of my so-and-so, I got less marks. Oh, because of this, that's gone. That's a recipe. That's a failure uniform. Please, anything that happens anything that happens bad is because of you only. Anything good happens is because of your team or somebody else. Just like that's it. Be ruthless about that. I don't know of a better perspective, right? Fast implementer, I think we've talked about that. Be persistent, be a roach, be humble, just be the same, be essentialist. So like Zuckerberg has only like 40 shirts, they say. Not the best example, but moral stories, just get away from like these materialistic things like, oh, I need a fancy car. Oh, I need like a 4 BHK. Why do you need all that? Just relax, right? I'll be honest with you. When I had no money, I went and bought a big car. Waste it was. When I have more money, I'm grateful. I don't need it. I'm still like, trying to just, it's difficult to do it. Okay. It's difficult to do it, but creative and humble, I think that those are kind of go tie in with the rest of the traits. Spiritual, we've talked a lot about that. I think by now you would have sensed it. So be that. I think the 3 pillars are IQ, which is straightforward here, intelligent quotient. EQ is emotional quotient. That's where people get off. SQ, spiritual quotient, is very important. I'm not talking religious, be spiritual, right? That's my belief. You can disagree with me. Okay, cool. So the updates, I think the only update I have since the last few weeks is the AI is also becoming the IITM thing. Metrics we're not going to measure. So with that, we will.
Rajeev sir, all yours.
All right. Thank you, Sachi. Thank you very much. I hope everybody is able to hear me. And so let me share my screen first. All right. I think everybody should be able to see my screen. And let me hide this. All right. So let me first get the All right, folks. So we started talking about, and I believe most of you, were there in the last session. If not, I am Rajeev Kumar, and I am taking you through first. I mean, what we'll be doing, what we started last week. We'll continue to go through several Python sessions so that you are comfortable with Python for data science, and so that you can start your modeling, ML modeling journey, right? EDA, ML modeling, and so on. So we are currently learning Python. So if you have attended the last session, great. If not, please go through the last session because it's hard to recap every time. And I mean, so if you've not listened to or gone through the last week, the session, please do that. So let's get started. And what we're going to do last week, we learned about some of the basics of Python. Why how things work in Python at a very basic level, right? So and in that session, we talked about a package called NumPy, or a library. We can say library is more a name which we use in different languages. Library called NumPy. Right. So what did we say, folks? Why do we need to use NumPy? What is the reason for using NumPy? So you can either speak up or you can put your answers in the chat. I have the chat window on the top of the screen. So you can put it there, and again, don't worry about being right. If you so here we are here to learn. All right, Parikshit saying it's easy, and Gayatri is saying it's faster, right? Faster. Satvik, processing speed is for mathematical operations. It's faster, right? Yeah, and that is the key. That is the key. It is Python, right? It's basically faster. NumPy is faster rather than using the list in Python. So we have a list, and then we have NumPy arrays or NumPy. Now, why did we say it is faster, folks? Why is it good? Why is NumPy faster than working with Python list? It makes numerical operations easy. That is true. Codes are all right. Very good, right? So as Shiva and Satvik rightly pointed out, NumPy is not truly a Python library. It's not a Python library, rather it's a C library. Now some amount of it is C++ and some amount of it is C. So it's C, or probably majority of it C, and then some amount in C++. Now, so the most of the code is written in C and C++. Now, how can C++ or C, why are they faster than Python? So although we interact with NumPy using Python, but it is most of the code is written in C or C++, and that's why it's faster. But why is C++ faster than Python? Gayatri is thinking it's OOPS, which is object-oriented programming concepts. Gayatri, is that? I guess that's what you meant by OOPS, right? Yeah, yes, it's not OOPS, right? So, so now the question is, do we have OOPS concept in Python? Absolutely, we do. So we can use object-oriented programming in Python, right? Now let's now DSA and Nandakishore, what are you thinking about DSA? What do you mean by DSA? Expand on that one. Nikhil is saying, I believe that library automatically clears garbage and huge operation and memory operation. Kind of, yes, data structure algo. All right. Now let's understand why Python is slower than C++. Now, let me write. Now, let's say A is 5. A is equal to 5. Now, if I run this code, folks, let's say I'm going to run this code in our Jupyter notebook. what type of variable is A? What type of variable is A? It's an integer variable, right? I mean, and how do we check its variable? So I did not talk about it, but if at any point you want to check the type of a variable, just say type and just say just pass the variable name, and if you run it will tell you it's of integer type. Now, on the other hand, let's say I'm continuing with right now A is integer, but I can say A is Rajeev. Now, what is the data type of A? Right? Data type of A is string. str stands for string. Now, thing is, you notice that we never define what is the type of A. What is the type of A is dynamically decided at the runtime. Now, this is not possible in C++ or C or Java, which are compiled language. There, every variable we have to first define what kind of variable it is. Is it an integer? Is it a string? Or is it a list or something? I mean, for example, I can easily make A as a list also. And if I check type of A now, it will say list. But that's not possible in the languages where code has to be compiled first, like the C, C++, and Java. Right? Because there are a lot of restrictions, which means because you're compiling the code, there is like two-step process. You write your code, compile, and then run it. Here, we're writing and then immediately running. So, because our code, Python doesn't know what kind of variable it is going to work with, it has to decide at that moment itself, hey, all right, we are working with string, and let me see if I can do something with this right now. Right? Obviously, that slows down Python. Right? So, each has an advantage, but Python gives you it gives you a lot of freedom in terms of trying out different stuff. So, I mean, here, I mean, you cannot write C++ code like this. You have to write, compile, and then only then you can run. Yeah. So that's the difference. I mean, I was thinking in real world, if you think about, it's like, let's say you have some work. I mean, let's say you're hiring people, and you say, okay, let's hire a person, versus let's hire a person who has a knowledge of finance. Right? Now, so, the difference is Python is like, okay, we have a person hired. Now, after the person is hired, we check what the person can do. Right? Can the person do the job that we have? On the other hand, C++ is like hiring a person with exact required skill. So when we hire, so the hiring process is long, but once the person joins, he or she can quickly get to the work. But that may not be the case with Python. Right? So just kind of I don't know if does it make sense? The hiring process is slower in C++, or basically, with exact skills, and Python is more like, just hire a person. We will later on see what skills the person has. Yeah. So that's the difference between, that's why C++ and C are faster, but they're harder to learn. They have to write a lot of code. So people prefer Python. So we have a library, NumPy, which is written in C and C++, but it is accessed through Python code to make it easy to work with this C++ or C code. All right. So today, what we're going to do, yes, last time we saw basics of Python. Today, we're going to spend some time with NumPy. Now, why NumPy? Because in AI, and machine learning, we basically work with data. And NumPy is basically, the name NumPy stands for numerical Python. Right? So NumPy library is built to work with data, and that's a lot of data, right? So we saw that last time how NumPy can be much faster than working with Python lists, right? Now, for example, let's say I have a list, A is equal to 1, and then I say Rajeev, and let's say 2. Now, if you see here, folks, my list A, now if type of A is still a list, but what kind of data A has, folks? What kind of data is inside A? Mixed. It is mixed. There are some number, there is some string as well. On the other hand, when we use NumPy, you cannot have mixed types. If your data is integer, everything has to be integer if in a list. If your data is string, everything has to be a string, right? So it's not, so we put some restrictions to make NumPy faster because we're going to sacrifice speed by keeping some constraint on what kind of data we are working. All right, so let's see how things work in NumPy, right? Now Nikhil's question, Rajeev, that basically it's like an array. Yes, now NumPy, see, data is, data is, you can have data as an array, right? Now you can have a non-NumPy array in Python. You can have a list, or array in Python, and you can have array in NumPy. So NumPy is, of course, has arrays, but it also has mathematical operation that we can use on arrays. Ultimately, see, once we have the data, we want to do something with the data. And maybe it's multiply with some value, add some value, a square, or what, we need to perform some mathematical operation. So NumPy also has all of those mathematical operations. So NumPy is literally a math library, folks. It is a math library, right? And we will see that today. So let's get started. So what we're going to do today, we have seen why it is fast, but let's understand what we're going to talk about NumPy today. First, we will talk about how to create NumPy arrays, right? Then we will work with some random numbers. Now you in artificial intelligence, machine learning, quite often we work with random numbers. And why? We will learn that when we get to machine learning part. But we do work with random numbers, and NumPy can help us get those random numbers. Then we talk about some of the methods. Now, indexing and slicing, how to access different elements in a NumPy array. We'll do that. And then we'll talk about NumPy operation. As I said, we have to perform math operation on our data. So NumPy provides all those math operations. So we can use that. We'll see some of the popular operation, how to perform them. And also we will see how can we store the data on the hard disk, right? I mean, suppose let's say you modified the data and now you want to use it in another program, right? Or you want to send it to someone, then you will need to save it on the hard disk. How do we save the data on hard disk? Or how do we read data from hard disk so that we can perform some math operation on it? So we'll see all of that and more in this session. So this session we will be getting into nitty-gritties of using NumPy arrays. Now, don't worry about memorizing the code. You will never ever be able to memorize the code. Nobody has been able to. So don't worry, right? So you will have the notebook with you and you can practice with it later on. But but we will see. So if you have any question, ask that, right? And and then we're going to break our code also at times. All right. So first thing is we're going to talk about is how do we create NumPy arrays. Now, what is an array, folks? First of all, see, arrays is nothing to do with NumPy. What is an array, folks? What is an array? A container, yes, Siva says a container, a collection of data, yes, absolutely, collection of data, very good, right? It's a collection of data. Now, so it's a, so because a lot of time we're working with a lot of data, so we want a collection, easy way to work with that data. So we use array. Yeah, we use array, collection of data. Very good, right? It's a, right? Now let's understand how do we create NumPy arrays? How do we work with arrays in NumPy? So this is, folks, this is what I'm declaring in this line. This is a list. This will be, what type will it be? It will be list, not int. Yeah, it is an integer array, but it's list, right? Now, the thing is, now how do I create a NumPy array? I can create a NumPy array from a list as well. I can convert a list into NumPy arrays. So I'm passing a, which is a list, and this is the form. Now, what I've done, I have imported NumPy at the top of the program as an NP. NP is the short name for NumPy. In this case, I'm using, you can give any name in Python, whatever you want as a short name, you can call it, whatever BB or whatever you want to call, but NP is quite popular for NumPy, so people use it quite consistently, I would say. So now let's see, if I say NumPy A, it will create a NumPy array for me. Now, okay, now what happened, folks? Why are we getting this error? Right now, I usually say errors are best way to learn programming, right? Because if everything works, there's hardly any learning, right? Why is it? What is the issue? It's saying name error. You look at this, NP is not defined. It's saying NP is not, and we say why NP is not defined? Did we not import NumPy earlier? And we did not. Can you see this, folks? This particular cell has not run. You don't see any 1, 2, 3 here. Right? So we need to first execute. All right. Now let's go back to the code and see if this time it runs. It ran this time. Yeah, it ran this time. So now earlier A was, I mean, if I had, earlier if I had printed A, it would look like this. It's a list, and now it's an array. It says it's an array. Now, if you want to know the data type of this, you can always say type, and let's say I'm converting it to NumPy array, and let's say A. If I check the data type, because, see, if I say, okay, let's say A2 is this, and let's say I'm printing A2 here. A2 is the variable name. Now, what is the type of A2? Let's understand. So it is, you see this, folks, it's a ND array, NumPy data array, right? NumPy data array, right? It's not a list. For example, A was a list, but A2, which is a NumPy array, is NumPy.nd. Now, so we can create a NumPy array from a list, existing list. Now, second thing is, now what would you say, what is B, folks? What is B? Now, does B look like a slightly different type of data? It's a, now is it an array or a list? It's a list. It's a list. So you will have those square brackets around list, right? Now thing is basically, now here, what is B? It's basically list of lists. There are, each element of list B is a list in itself. So it has two elements. We can always check the length of an array. So there are two elements, and each element is a list. So it is a list of lists or nested lists, as Satvik says. Now, if I convert this into an array, so this becomes. So is this an array? Yeah. So this is an array. It's a two-dimensional array. It's a two-dimensional array. Now, have you learned about, dimensions of an array? Are you familiar with dimensions of an array? Yes, right? Absolutely. Now, if you think about, let's say I have a number 32. Let's say I have a number 32. So how many dimensions are there of this data? 32. Yeah. Is it single dimension? Yeah, one dimension, right? Now, let's say if I have a thing like 32, 45 minus 90. Let's say I have this. let's call it, let's say this is A, and let's say this is B. Now, what is the dimension of A, folks? What is the dimension of A? It's all right. So it's not 1. I know it looks 1, but it's actually 0. Dimension of A, which is because it's a single number, is 0. So when you have a single number, it's single number, we call it scalar data. Scalar data. That's okay. Don't worry. I mean, it's just a terminology, right? It's a terminology. On the other hand, what is the dimension of B, folks? What is the dimension of B? Is it scalar or now here? If your data has 1 row of data or 1 column of data, this is called one-dimensional. One-dimensional. If you have 1 row of data or 1 column of data. For example, let's see, number of marks in math exam for all the students in a class. So student number 1, 32, student number 2, 82, student number 3, 73, student number 4, 45. So we'll have a list which will basically be representing marks for each student in the class in math. One dimension. Now, on the other hand, let's consider another variable. What about this one, folks? C. Variable C. What kind of data is there? How many dimensions are there for this data? How many dimensions? This is 2-dimensional. This is 2-dimensional data. Right? 2-dimensional data will have rows and columns, multiple rows and multiple columns. 2-dimensional data is quite popular. It's like, if you think about it, it's like let's have marks for math and English and science for all the students in a class, right? So for example, now let's say there are 3 students in the class. So this represents marks in math. Let's say this represents the students' marks in English. And let's say I create one more, and these represents, I'm just changing the numbers. These third ones represent the marks in science. So marks in math for 3 students, marks in English for 3 students, and marks in science for 3 students. So how many dimensions C has now? How many dimensions C has now? Satvik says 2. All right. Is it 2 or 3? Yeah. Prajali, Shantri, yeah, right. Now thing is, this is still 2-dimensional data, folks. This is 2-dimensional data. So it might look, now the thing is, in this case, let me show you. I will copy this to our another, and it'll be easier to visualize there. So let's say C is this, and I'm going to convert to NumPy array and C. All right. Does the data look exactly like what we saw, what we have written in C? It's just arranged little more visually better. Pranjali and everyone, does the data look the same? Yes or no? Yeah. Now, why is it 2-dimensional? Now, 2-dimensional means your data will have rows and your data will have columns. Now, it's not that it's not that you cannot have 3 rows. You can have 3 rows, you can have 4 rows, you can have 5 rows, you can have 6 rows. Now, in this case, we have 3 rows. This is row number 1, row number 2, row number 3. Right? We have 3 rows. Right? But there are only 2 dimensions, rows and column. Rows and column. Yeah. If I add, let's say, marks for another subject, let's say, what do you got? Environmental science, let's say. Say marks. It is still 2-dimensional data. Only thing is now we have 4 rows and 3 columns. Still rows and columns. So if your data has rows and columns, then it is 2-dimensional. Sometimes we say if your data has height and width. Like height is like, going, this is the height and width is 3, right? So rows and columns. In this case, we had only a row, 1 row. Now, if there are 4, Pranjali, what are you thinking? We have 4 rows now. Yeah. Yes. What do you mean by 4? If there are 4, then see, it's not. See, we can have 1 more. I can have 1 more. I can say 1 more, and it is still 2-dimensional. Now it is a 5 by 3, 5 rows and 3 columns. We still have rows and columns. So what is 3-dimensional data, folks? Now, so another way to understand, okay, if all of this is 2-dimensional, then what is 3-dimensional? What do you think? Do you have any example of 3-dimensional data? Yeah. Right? So what is 3-dimensional data? 3-dimensional data is a picture. A picture. Now, does the picture have height and width, folks? Does a picture have height and width? Does it, a picture has height and width? Yes. Like we have, see here also we have height and width. We have rows and rows are called, rows is equivalent of height and column are equivalent of width. Then how come now? So that is 2 dimensions, height and width. Now, what is the 3rd dimension of a picture, folks? 3rd dimension is depth. Now, what is a picture? Now, picture is made up of pixels. At every, think of this as this point is a pixel, this point is a pixel. Now, a pixel on a picture is not represented by 1 number usually. If it is a colored picture, it gets represented with 3 numbers. That means the depth of the pixel is 3. So we have a depth also in the picture. That's the 3rd dimension of the data. Yeah. So picture is 3-dimensional. Pranjali and everyone, does it make sense? So most of the time you will be working with 2-dimensional data, rows and columns. If you're working with pictures, then you're working with 3-dimensional data. And anybody has an idea about what a 4-dimensional data will look like? What is 4-dimensional data? Does anyone? Yeah, Pranjali. All right, good. Right now, I know. So it's not that we need to have only 2 rows, 2 columns. You can have as many rows and as many columns. But if you have only rows and columns, then it's 2D. Right? Right. Time. Now, if you think about, let's say, a video. What is a movie? Movie is nothing but pictures after picture. Right? And after every few fraction of a second, you have a picture. So the 4th, so every picture is 3-dimensional, height, width, and depth. Now, in a video, the 4th dimension is the time, because at every time we are showing you a new picture or new image. So time becomes the 4th dimension. So if you're dealing with video, you're dealing with 4D data, right? So we have, again, you can have 5. It's hard to get 5D, 6D, and 7D, right? So usually data is either scalar, which means we are dealing with a single number like this, or one dimensional where we have only one row or one column. Either we have a row of data or we have a column of data, not multiple rows and multiple columns. Either one row or one column. Like, for example, you can say, I have one row of data. In this case, I have 3 columns, but number of rows is only 1, exactly 1. So this is one-dimensional data. In this case, we have 3 rows and 3 columns. Or if you go to our other example, here I have 5 rows, 5 columns. If you have multiple rows and multiple columns, and if you have only rows and columns, not depth, then it is a 2-dimensional. Is this part okay, everyone? Yes or no? Let me know if any confusion. I know, first time when we talk about it gets confusing, but I hope at least a little bit clear, right? All right. Okay. So we can see that we can work with now, that's why we say we can work with multi-dimensional data. Now, a 0-dimensional data is scalar data. What is one-dimensional data called, folks? There are some terminologies that you will use. What is one-dimensional data called? Like data like this, it's called vector. It's called, very good, right? I'm absolutely right. It's called vector. What is 2-dimensional data called, folks? What is 2-dimensional data called? The name for 2-dimensional data is matrix. You would have heard the term matrix. It's just nothing but a 2-dimensional data. Matrix will have rows of data and columns. Rows and columns. Make sense, everyone? So this is a matrix. And what do we call a 3-dimensional data? What do we call a 3-dimensional data? Well, there is no special name for 3-dimensional data. We just say it's a 3D array. And 4-dimensional data is 4D array. So there are no special names given to higher dimensional data because it's very rare. So what is the point of getting a name for it, right? So usually you will have scalar data, single numbers, vector, either one row or one column of data, and matrix. And then if you're working with pictures, then you're dealing with 3D, or video is 4D. Otherwise, most often you will work with 2D data, right? If you think about all the databases in the world, right? They have tables in them. Table is nothing but 2-dimensional data. It has columns, which are the fields in the columns, and then you have number of examples. Those are the rows of the table. So tabular data or table data is the most popular data because every company has tabular data and it's a 2-dimensional data, right? Now, Bhanu has a question about tensor. Now, tensor, we will talk about later, but just tensor, think of tensor as another name for array. Another name for array. So don't worry about, sometimes we use different term and we do that a lot in machine learning. You'll hear multiple jargons in machine learning, meaning the same thing. Now, there is a reason why I'll talk about that reason later on. But tensor, we'll understand later what tensor means. But think of this as an array, Bhanu. So you can have a 1-dimension tensor, 2-dimension tensor, 3-dimension tensor, 0-dimension tensor, which is scalar tensor. Yeah? So it's just another word for array at this point. Yeah. All right. So is everybody comfortable with the dimensionality? Right? Now, Prashant is saying scalar data is a single number. Single number. Like this is A is equal, you have one number, 32. If you're just dealing with single number, Prashant, that's what we call you're dealing with scalar data. When you're dealing with multiple numbers or multiple data points, then we think of 1D, 2D, 3D, depending on how number of rows and number of columns. Yeah? All right. Okay. All right. Wonderful. So now going back, scalar, vector, matrix, 3D, 4D. Absolutely, Siva. You're right. Now, folks, now now take a look at this. This is, now you look at B and C. Here we have B. So how many dimensions in B? How many dimensions in B? 2D. What about C? How many dimensions in C? Still 2D. Now B is 2D and C is 2D, but are they of same size? No, they're not of same size. Yeah? They're not of same size. So how do we say, hey, both are two-dimensional, but they're not of same size? Yeah? So we have another term. Let me see if we have it here. One quick moment. Okay. All right. We will talk about that a little later. How do, what do we mean by, although dimensions are same, but how do I say, A, C has different amount of numbers and B have different amount of numbers? We will learn about another term to distinguish same dimensional data using a attribute or using an attribute called shape. So we have an array has a dimension. So you have to express number of dimension, and then we will talk about shape in a few minutes. So then it will be even more clear. Yeah. All right. So first thing is we can create a NumPy array from a list. Another way to create sometimes we create array using this function called a range, right? A range. So if I say a range and give two numbers, it will create a NumPy array starting with the first number and ending at the last number -1, second number -1. So you can see it starts from 0, which was the first number, and 10 is not included. Last number -1. So it creates a NumPy array. So this is another way to create a NumPy array. Yeah. Right. Okay, Nikhil, yes, I think we will talk about more about number of elements in a few minutes. Okay. All right. Now you can also give a step size. When you're using a range, you can give a step size. So here, for example, I give a step of 2. That means 0 will definitely be my first number in the array, but then 1 will not be there. It will be 2, then 4, and 6, and so on. So it will be 0, 2, 4, 6, 8. Now again, this now sometime in machine learning, sometime we use NumPy arrays of zeros. For example, I am creating a NumPy array. Now what is the dimension of this array, folks? What is the dimension of this array? It's 1D. 1D. Right? Now there is, sometimes there is another difference between a NumPy array and a list. See, we said in a NumPy array, you cannot have examples, different type of data. For example, if I go back, see here, all of them were number. Now, if I say, let's say I change 3 to Rajeev or some word. So my data, my list will accommodate it, but when I convert it in a NumPy array, it will, okay. What did it do, folks? What did it do when I converted B into NumPy array? It's not, there is no error though. It's not throwing an error, first of all. If it throws error, that's a nice thing. But it did not throw an error, but it did something. If you notice, everything became a string now. Right? We had numbers, but as soon as it realized, oh, there's a string, everything was made a string. Right? So a NumPy array can have only one type of data. You cannot have different type of data, unlike list, Python list. Yeah. So that's the thing, right? Now, another thing is in a Python list, you can add new numbers or new data. For example, let's say I have A here, and I believe there is A dot add or something is there. Maybe, I don't know. Let's see if I can try 7. Let's see if Okay, doesn't have add, but you can always add more to the list. Sorry, maybe it's you can add to the list. You can append. Okay, yes, absolutely. Well, how can we use this append? Let's say I append 79, so that at the end it will get appended. Yes, and if you print A now, it will have 79 there. Thank you, Gautam. Right, append. Now, thing is, now this seems, this kind of reasonable thing, but you cannot append things to a NumPy array. So NumPy has several restrictions, right? You cannot change amount of elements or an amount of members in a NumPy array. Whereas in list, you can change it. You can have different type of members. You can add or remove members, but that is not possible. So to make it faster, there are few restrictions. Yeah, yes, Prasad, that is the word. The word that sometimes people use is immutable. Immutable means you cannot change the size of NumPy. Append is like adding another member. Pranjali, append is like adding, let's add one more student to the class. Yeah, so it's like, yeah, so that's what it does. Pranjali, is that okay? Yeah, so it's basically adding, like if you want to add one more element to the array, like 79 got added. Yeah, all right. Now coming back, now quite often we need, so what we do, folks, usually let's say we are working with some model, and in the beginning I will not have my numbers that I need in NumPy, but I know how many numbers I will be working with. So quite often what we do, we create a NumPy array with some, maybe just initialize the values with 0. See, I can change the values of the number, but I cannot change the size or dimension of NumPy. So quite often a lot of time we initialize our arrays with zeros. So size gets fixed, but values can be changed for these numbers. So this is one-dimensional array. Similarly, I can have two-dimensional NumPy array of zeros. Now, what is this 4 by 2 means? What does this 4 by 2 means? The first number indicates how many rows of numbers you want, and the second number says how many columns numbers we want, right? Now, do you want to see how a three-dimensional array looks like? Yeah, we have not seen three-dimensional array. So if I make it, let's say I want to have a 3 by 6 by 2 array. That means 3-dimensional, right? 3, 6, and 2. So and this is, folks, with 1. So every value will be 1, but see how it looks. It looks a little weird, but it's hard to look at, but this is the 3-dimensional array. So you will notice that it starts with 3 square brackets. You notice this? Yeah, 3-dimensional. Whereas the 2-dimensional array will have 2 square brackets. 1-dimensional will have 1 square bracket. Now, just to kind of think about it, right? So this is 3-dimensional. So you can start you can create, these are method. You can create arrays of zeros, arrays of ones, and of any shape. You have something called linspace. So, for example, linspace is basically a give me now just some function to create. So what we are saying, I want my NumPy arrays to have 5 numbers only. Now, what should be those numbers? Numbers should start from 1 and end at 10, but all those 5 numbers should be equidistant from each other. So let me show you what the output look like. All right, you see this, folks? So so each number has the same difference between them. Yeah, right. Now, okay, so Nikhil has a question before this, okay, and it's important to clarify. Rajeev, in this 362, does 3 indicates 3-dimensional data? No, I can make it 5 and it's still 3-dimensional. That means, how to read this? Think of 5. The first number is number of rows. Second, number 6 is number of columns. And third, number 2 is the depth of the array. Height, width, and depth. Rows, column, and is that okay? Right? So yes, I removed 3 so that it doesn't confuse with 3D. Yeah. All right. So it's basically, yes, the automatic differentiation. The difference between each number is 2.25 in this case. Yeah. Similarly, we have something called I matrix. Now, what is I matrix? Now, I'm giving a number 5 here. Now, what it will do? It will create a 5 by 5 matrix, 2-dimensional data, 5 rows and 5 columns. And you see this. I'll come to this. I'll come to why 2.25. But do you see this, folks? What is an I matrix is? I matrix is nothing but a square matrix. Square matrix means number of rows and number of columns are equal, and the diagonal values are 1. Now we might use this sometime. I matrix. It's called I matrix. Right? Now the question is, why do we have 2.25 difference? So it is 10 minus 1 divided by 4. As Rohit absolutely rightly said, 10 minus. So we're going to start with 1. After that, we need 4 numbers. And the last number is 7. So 10 minus 1 should give me 4 numbers. Nandkush, is that okay? So 10 minus 1 by 4. Right? So it can. Now, a lot of times in machine learning, we have to work with random numbers. What would be a random number? Random number is basically we don't specify what number we want. Randomly choose some numbers. Now, there are different ways to choose random numbers. Now, you will learn as you learn about statistics. So random numbers, there are different ways to choose random number. One of them is called uniform distribution. So here what I'm saying, so this is numpy random.rand. Ran. Here I want 4 random numbers. So if I press it, it creates a numpy array of 1 dimension with 4 numbers. Now you see this, folks? These numbers, I got it randomly. The numbers will be between 0 and 1, folks. All the numbers that will be given to you will be between 0 and 1. Now keep an eye on this. Now if I run this code again, folks, you will get a different set of random number. Let me run it again in another cell, and you will see that random numbers are different. Although I ran the same exact code, but every time there are different numbers. Now, how many numbers are there, folks? How many numbers are there in this work in our number system? How many numbers are there in our number system? Right? 0 to 9, yes. 11, 12, 13. Yeah. Now, can you tell me how many numbers can we get between 1.1 and 1.3? How many numbers can you give me between 1.1 and 1.3? Will it be infinity between 1.1 and 1.3? And the answer is yes. Right? You will have 1.11, 1.111, 1.111, and you just, there are infinite numbers between any 2 given numbers. So we're working with a lot of numbers, folks. Right? Now, so these numbers are getting generated randomly. So if I want 2-dimensional array, now what is the first number indicates in this in 2, 3, folks? What does 2 indicates? What does 2 indicates? And what does 3 indicates? So it's not start and home. So in this case, Satvik, it's not start and end. It is number of rows and number of columns. Let me show you. We are getting 2 rows of numbers. Each row has 3 columns. Is that okay, everyone? 2-dimensional data. You can change it. I can have 5 rows and 10 columns. It's still 2-dimensional data. It's just a bigger, right? Bigger this thing. right? So there is another way to generate random numbers. Again, you will learn more about it, normal distribution and uniform in statistics, but that also approach. So here I'm generating 4 by 3 random numbers, 4 rows and 3 columns. Now here we are working with what kind of random numbers are we getting, folks? What kind of numbers are these? What kind of numbers are these? Floating point, floating point. Now, I mean, you can always check what kind of data type is this. I mean, we will check it, but let's say I have X is equal to this. And if you say type of X, it's a floating point number. Yeah? So we have a integer data type, we have a string data type, we have floating data type, we have list data type, we have numpy.nd array data type. So we have a lot of different data types in Python, and Python doesn't know what data type, it knows only when you execute them. So that's why it's slow, folks. Right? So that's why it's slow. Now, question from Rohit. Rohit's question is, can you please make graph of random so that we can understand uniform distribution? Okay, maybe in the next one I'll explain. All right. Okay, maybe let me see if I can do that quickly. One moment. All right, let me. Okay. Or rather, have you read about random and uniform distribution? First of all, everyone. If not, you read about it and then we will discuss in the next session anyway. Because it takes, right? So maybe Rohit, you might have read about it, but let others also read, and we will take this up. Remind me in the next session, and we'll spend a few minutes to clarify, right? Because otherwise we will miss out on NumPy operations. Okay, so remind me on that next one. And by the way, folks, read about uniform, random numbers, uniform and normal distribution, random numbers, and we will talk about it more with the graph next session. Rohit, is that okay? Yeah. All right. Now, thing is, we need not get only floating point numbers as random numbers. We can actually generate integer random numbers. How? For example, here, folks, what I'm doing. What does 5 and 20 will mean? I know it's what will 520 will mean? So this is again, no, I'm just messing with you guys. This is not rows and columns. It will give you exactly one number between 5 and 19. So I know it's weird. I mean, I agree with you guys. I mean, this is messing with our brain, but this is not number of rows and columns. Again, don't worry about memorizing it. But if you want a single integer value, that means scalar value, folks. I'm getting only one number. That means I'm generating scalar between 5 and 20. So we can get it. You can change this upper limit, lower limit, right? Randint, right? Randint, right? Instead of random. Similarly, if I want 3 numbers between 5 and 20, I can just say third is this thing. Now, if you want, this is one-dimensional array of 3. If you want 2-dimensional array of integers, then what you can do is you can give it 5, let's say 4. Then it will be generating you 2-dimensional array of 5 rows and 4 columns, and every number will be between 5 and 50. Right here, there is no difference of 3. This 3 means Siva, that we need 3 numbers. So you see this 9, 8, and 7. We got 3 numbers. Yeah? So this is just how many numbers do you want? If I want 5, I got 5 numbers. Yeah? So that's it. Now, so now if you see here, think about here, every time I run, I get different numbers. Right or wrong, folks? Are we getting different random numbers every time we run it? Yeah? Yes. Are we getting different numbers every time I run the same code, folks? Yes. Now, sometime that could create a problem. Let's say you build an ML model. Now in ML model we're building, we use random numbers. So you run the model, you said, hey, I got built very good model. Now if your friend runs the same code, he or she gets a different model. Why? Because every time the random number changes. So your output also changes. Now, in case you are looking to have exact same number generated, although randomly, but if you want the same number to be generated, there is something called seed. For example, let's say I'm going to generate 3 numbers. 3, 6, 80 this time. If I run it again, I will get 80, 20, right? Different numbers, we know that. But if you set a seed, you see this, folks, seed. If you set a seed, then what happens? Now, once I have set the seed and if I run, although I will get different, so I got these random numbers 52, 93, and 15. But if I run the same code again, I'm going to keep getting the same random numbers. My random numbers are not changing because I set the seed. Make sense, everyone? So this random seed is a way to get same random number every time you run the program. So if I set the seed in the beginning of the program, then my random numbers, wherever I generate, they will be same. Make sense, everyone? So how to kind of fix random numbers? So that's, although they're random, but at least we are getting same random numbers every time. That's what seed does. All right. Now let's talk about shape, another important thing. And so earlier we talked about 0-dimensional data, 0 means scalar data, 1-dimensional, 2-dimensional, 3-dimensional, right? Now there is another thing about arrays. Not only dimension, we talk about shape. Now, for example, right? This is, so what is the dimension of A, folks? What is the dimension of A, array A? Is it 1D, 2D, 3D? 1. Similarly, we know that B, also it's not scalar, Nikhil. This is 1D array. Scalar is just a single number, right? Right? Is that make sense, everyone? Yeah. So now, yes. Now this is 2-dimensional data. Now there is something called. Now let me show how to check the do we have the okay? No. Okay. So how to find out that if you, let's say you have a numpy array, how do we find the dimension? So you can say n dot n dim, or sorry, you can always say numpy dot n dimension. What is the dimension of A? I think this will work. Let's check. You see this, folks? It's saying dimension of array A is 1. And if you say a numpy of n dim of B, it will say it is 2. Make sense, everyone? That's what I was asking, right? A, 1, 2, 3, 4, right? Now, can we generate, now scalar data, we don't use numpy with scalar data, right? So it's a 0-dimensional array. Now, there is another attribute, another way to represent a array, and it's in the form of shape. Now, what is the shape of A and B? Let's understand. Shape tells you, first of all, it's saying there are 20 rows, or you can say 20 rows and 1 column, or 1 row and 20. Because A is 1-dimensional data. So there you can see there's only 1 dimension. Now, why this number is 20, folks? Why is this number 20? Why is this number 20? Because we have 20 numbers in this A. We have 20 numbers in this A. That's the shape of A. Now let's look at B, shape of B. Shape of B is 2-dimensional data. We know B is 2-dimensional. Now what is the shape of B? 4, 3. Now what does this 4, 3 indicates to you, folks? rows and columns. We have 4 rows and 3 columns. You can see there is only one dimension. There is only one number. Here we have 2 numbers in the shape. That means 2 dimensions. Yeah? Right. If you have C, let's say we create a C, and let's I'm going to just copy this as, let's say 5, and let's say 2. Oh, sorry, I wanted to have C. So C is how many dimensions, folks? C, 5, 2. What is that? How many dimensions? This is only 2 dimensions. Now, what are those dimensions? What is the shape of C? Is basically 5, 2. 5 rows and 2 columns. Yeah. All right. Wonderful. All right, folks. So everybody understand the difference between dimension and shape? Dimension says, do we have rows, columns, depth, and all that? How many dimensions? And shape says how many rows, how many columns, what is the depth, and so on. Yeah? So shape tells you what is the value of each dimension. What is the value of each dimension, right? So you can reshape, like, for example, I am creating a, okay, where is C? Did we have a C? I did not create a C, or did I create a C earlier? Maybe I did. Where is C? All right. That is weird. Let's reshape. Okay, reshape is what? Okay. Okay, we are creating. All right. So, okay, we are reshaping A. So, what is the shape of A, folks? Right now, A is 20 numbers, but in 1 dimension. Let's say I want to make it 2-dimensional array. Now, when I reshape it, I still need to keep only 20 numbers, but I can create 2 dimension. I can say, okay, convert A into 2-dimensional data where it will have 4 rows and 5 columns. So the C still has 20 numbers because A also had 20 numbers, because we are just reshaping A to become C, but you basically, can reshape NumPy arrays. Right? So this is what we can do. Now there are, some math operation you can do. Like, for example, let's say I want to find out what is the maximum value of in a NumPy array. We can say max. So I can always find max. It says 0.96 is the maximum value among these numbers. Now there is something called argmax, and sometimes you use it. Let's understand what is argmax tells you. So argmax says 8, folks. 8. Yeah? Now what does this 8 means? The argmax. What does this 8 means? Do we have any 8 number in this array B? Yeah, I guess there's no 8, but how come we are getting a number 8? So it's saying the maximum value belongs to the 9th element, not 8th. See, 8 means it's the 9th element. Why? Because it starts at 0, 0, 1, 2, 3. So it starts at 0. So this is the 8th index. This is the highest value. Yeah? So you will use that. Similarly, you have minimum and argmin. So argmin gives you position of the minimum or maximum, right? Whereas min or max give you the minimum or maximum value inside it. Another thing, you can actually check the data type of a NumPy array. For example, our A was a list or array of 20 numbers. What is the data type? Now, if you want to check what kind of elements are there in this array A, you can use a attribute called dtype. A.dtype. So what should be the data type of elements of A, folks? What type of numbers are those? They are integer. So data type, it says int 64. What int 64 means? It's an integer value. Now, what does 64 means? What does 64 means? Anyone has a thought? Again, you're not supposed to know, but 64-bit, exactly. What it says, that every number in this array is going to take 64-bit of memory. Now, 8-bit is 1 byte. That means each number will be stored in 8 bytes. 8 bytes, right? Similarly, B, because B is built up of random numbers or floating point numbers, the B's data type will be float 64. Now you can change it. You can change it. For example, I'm changing A data type. A is currently in 64. I'm changing it to float 32. How? By saying as time. As time. So let's change it. Now, do you see any difference between A here and once I change this data type? Do you see any difference? Yeah. So all the numbers are same, but this is 0 point, 1 point, 2 point, 3 point. So they become floating point numbers. Yeah. So that's the, so we have to remember, like usually we are either working with floating point numbers or integer values. Yeah. Yes. Right. So this is how it. So floating point. So you can check the data type and you can change the data type of array elements. All right. Now, how do we access different elements or members of an array? So let's create a NumPy array between 11 to 24. Now, let's say I want to work with a particular member. Let's say I want to work with this. Is it 16? So if I say A5, it will give me the fifth or rather sixth element of the array. Sixth. Why 6? Because indexing starts with 0. So 0, 1, 2, 3, 4, 5. So sixth element. So it will give me 16 in this case. Right? Now this is another interesting way. Now I say, hey, I want to work with all the elements starting from element number at index 2 all the way till index 5, not 6. 6 will be excluded. So before this. So if I say that this will return 2, 3, 4, 5, 4 members of the array. So this is 0, this is 1, this is 2. So 13 came because I asked for 2. 13 also, 14 also came because I want all the numbers from 2 to 5, not 6. 6 the last number gets excluded. So I got all the 4 numbers starting 13, 14, 15, and 16. So you can basically access multiple members also. Right? You can access specific numbers also. Hey, I want to work with element number 0, index 0, index 3, index 6. So you will get 11, 13, 14, and 17. You can update. You can update. I'm saying, hey, element number 3, 4 should be made 100. So if I do that, it will get updated. You can see element number 3. Now, 3 means 4th value and the 5th value became 100. So you can update specific element. Right? Now, so this is one-dimensional array. Now, how does indexing or slicing works with slicing means? See, what is slicing? Slicing means you are getting a part of the array. So slicing the array. Now, if you're working with kind of, it's not, yes, I mean, you're working with, you're slicing, truncating. Now, we are not modifying the original array, or we want a subset. I think subset probably is more appropriate, Nikhil, because we're not modifying the original. It's just, we're trying to get a view of subset of array. So, Nandakishore's question is 3 to 5 means index only index 3 and 4, not 5, 3 and 4. So the last index 5 is ignored. 3 to 4, 3 and 4. 3 to 5 means 3 and 4. 3 to 6 means 3, 4, and 5. Yeah, so that's how it works. So let's create two-dimensional array. So I am creating two-dimensional here. You know, so this array has 4 rows and 2 columns. Oh, sorry, 4 rows and 5 columns. Now, if I say B1, what will we get, folks? What should we get? B1. What should we get? Now, it will not return the first number. It will return the first or the second row, not even the first row, second row, because first row index is 0. So 90, 45, 32, 89, 50. So we got, because I said, hey, give me entire row. Which row? Row number 2. Because in row number 1 has index 0, row number 2 has index 1. Now, if you want a specific element, you don't want entire row or column, then what you will say is you basically are looking for third row, element in the third row, and fourth element in that. So third row is this row, third row is this one, and in this I want the fourth element. That means we should get 45 here. So let's confirm that. All right, we're not at 22. What is wrong here? All right, I made a mistake. So third row is not this, third row is that. Right? And it is correct, third row. So it is third row, 0, 1, 2. That is third row and fourth element. So 22, not 45. So that was my mistake. Now, we can write the same thing rather than using 2 square brackets. We can write the same thing in 1 single bracket by saying 2, 3, and we will still get the same answer. Now, if you want, let's see. Now, let's understand this part. Here, what I'm doing, what does this colon 2 means, folks? Now, let me try to give you first. Let's run one by one. What if I just have this? What would I get if I say this from B colon 2 in the bracket? So in this case, what we are saying, give me all the rows before row number 2. So we will get row number 0 and row number 1. 2 rows we will get. Yeah? And if I do this, in this case, I'm saying, hey, give me first 2 rows. And because I'm saying column also, I'm saying, hey, give me all columns starting at position 3. 2 means index 2 means starting at third column. So if I do this, so I'm going to still go same rows. But now because I said index value should start from 2, so this is index value 2. So 6, 7, 8, 32, 89. So we can do indexing. Yeah, so we can do that indexing, right? And of course, so you can do custom indexing also. Custom indexing is, for example, here I'm saying, give me all the rows. Now, just using a colon means give me all the rows. But give me column number with index value 1 and 3. That means second and fourth column only. So if I do this, you will get only 2 columns, index 2, index 1 and 3. So 32 and 7. So you can do that. Now, so let's say our B is this. Now there's one thing you need to see is, let's say you have B. This is B. 2-dimensional array, 4 by 5 array. Now here, let's say I'm creating a new array C, which will have the first 2 rows of B and all the columns starting at second column, from second column onwards, all the values from second column. So this is C. Yeah. Now, what I'm doing here, folks, I'm setting every value in C to 200. So right now C has 2 rows and 4 columns. I'm setting all the values to 200. So if I do that, everything will be 200 in C now. Make sense, everyone? Right? So what I did, I just everything, every column, every row element should be set to 200. Now let's take a look at the value of B. Did B change, folks? Did B change in this case? Yeah. See, our B was this array. Did it change here? The values changed? Yeah. So you can see, yes, I mean, the first, I mean, you know, so basically C was not truly a new array, rather a view of existing array. A view. It was not a new array. So when we modified C, basically we were modifying B. So what if you don't want original array to be modified? That means you need a copy of original array. So how to do that? You can create a copy of an array. So if you don't create a copy, basically you're modifying the original array, folks. So if you want a copy, let's create a new one. This is B, and I'm going to create a copy of B, and I'm going to call it D. Now I'm going to make all the values in D to be 500. So every value will be 500. But if you check B now, it's original. Why? Because I created a copy of B, not the view of. So, I mean, here we create and you can always create a copy of a subset also. For example, this, if you want to do it here, you can always do that. So here, let's say I want to create a, like this is my D. Now if I make D, you know, so D is, everything is 500, but B, there's nothing 500. So we have to use copy if you want to preserve the data in the original array. All right, so there are some operation, as I said earlier. So first is we work with arrays, right? We have arrays. Now, once we have arrays, we have to perform some operations. What kind of operations? You can perform add operations. For example, let's say I'm creating a NumPy array of 15 numbers, 10 to 24. Now, if I say A plus A, it will create a new NumPy array where every element is added to corresponding element. So 10, so I'm adding 10 in first A with 10 in second. You can add, subtract, multiply, divide. So all those math operations that you can think of. What is this one, folks? Star, star. What would it indicate? Have you seen something like this before? So this is square, absolutely, right? Exponent, right? So 10 raised to power 2, 11 raised to power 2, and so on. 100 divided by A, that is, you know, in this case, 100 divided by 10, 100 divided by 11, 100 divided by 12, and so on, right? So this is, you know, so we can do all kind of math operations on our array. You can also do, you know, there are a lot of math functions written, right? Like, for example, if you want to calculate square root of each element, you just say numpy.sqrt. If you want exponent, that means e raised to power the value, then you can just say exponent. If you want to do square, just say square. You know, other option was that star, star 2. So, but you can do it this way also. If you want to calculate the sign value of each value of A, sign, right? Log of A. So, you know, so it's not about, you know, arrays. What is, see, once we have the array, that means we have the data, we have to perform some mathematical operation. And NumPy has all kind of mathematical operations already written in the code. So we just need to call that appropriate function and it will do the math operation. Yeah. So we have a lot of those, like, for example, rounding the numbers. So I'm rounding the numbers to 2 decimal place, right? So if I want to round to 0 decimal place, you know, you don't specify, you know. Now, sometime you will need to calculate standard deviation. Now, how many of you have learned about standard deviation? Yes or no? In statistics, right? Standard deviation gives you an idea about how much variety is there in your data, right? So standard deviation, you can calculate using NumPy of all the numbers, right? Variance is just a square value of standard deviation, right? Yes, absolutely. Average, if you want to calculate average of a number, just say numpy.mean. And it will calculate average. So all the math operation you can think of, you can do. Now, let's say I have these values. So far we've always worked with numbers in NumPy, but you can have a NumPy array of text. Now, there's one thing now here, folks, like some values are repeating. If you want to find out what are the unique values in my NumPy array, you can use a function called NumPy unique. And you pass the array and it will say, what are the unique values? It says these are the. Now, in this case, you see banana with capital B and with small b is taken as different value. So this is case sensitive. All right. Now that we have learned about, now let's say we have you perform some math operation and you want to store your NumPy array on hard disk so that you can use it in another program. So you can always do that, right? So I'm going to create, let's say, a couple of arrays, and I'm saying so you can use numpy.save, and I'm saying the file name will be AR_1, and I want to save array number 1 in the NumPy array. In this file, AR1, you can give it any value, AR1 file, you say, and let's say, or whatever name you want to give. So if I do this, now how do I confirm my file got saved or not, folks? How do we confirm? We can check the current directory because I've saved it in current directory. I can check the current directory and see. Do you see this, folks? There is AR1 file, that same name which I gave it, and automatically an extension is given .npy. Right? In Linux, there's a command called ls. Sometimes that is even better because you can, you can give those options. So it's saying AR1 file is 208 bytes. 208 bytes. Yeah? So that's basically your how to save. Now, of course, once you save, you can also load. If you want to load, you can just say numpy load and it will return a numpy array. Now, of course, in this case, because I changed the file name, nr1 file, if I change it, it will give me the numpy array. I'm reading from the list. Right? Now, you can save not just one array, you can save multiple arrays into a single, in a single file. So for example, here, so then you have to use this method called saves. So I'm specifying a file name, AR multi, and I'm saying array A is equal to array 1, B is equal to array B. So we have to give some object name. So, and then we save it. Now you can again confirm whether if this file got saved or not. So just check whether AR multi.npz. So you can see the file is, when you save it with saves, it is npz. Right? So now, if you want to load it, you will load it, but then you will have two arrays. So how do we access those individual arrays? Is by giving that object name that. So if you want to give B, it will give you the second array, which is 30. If you give A, which was the first array name, it will give you the first. So you can save it. You can again load it also. Now, usually, these are binary files. Now, if you want to save these as a text file, you have that option. So you can say numpy.text, save text, and you give file name and just say whatever is the numpy array you want to save. So it will save in that, and you can actually, if in Collab, you can actually see what all files you have. You can see that we have AR1 txt available here. You can double click on it, and it will show you those numpy arrays. So this is 11, 12, 13, 14, 15, 16, 17, 18, 19. Yeah, right. So you can see the text, what are the numbers inside in the file, and you can always load it and put it out there. Yeah. So this is what it does. So you can save your data once you have modified it using different math operations. So what we did, today we learned about how to work with different NumPy operations, right? How do we work with arrays, dimensionality of an array, shape of an array, right? Shape and dimensionality just tells you what kind of array you are working with, right? And then we saw different mathematical operations. We also saw how we can slice NumPy arrays. And finally, we saw how we can save and load NumPy arrays from hard disk. All right. So now what is now question? The question is, what is this delimiter? So delimiter is a way how to separate different values. So if you see here, although it's not visible in this case, but it would usually put a comma, which is not shown after every value, comma, 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 because delimiter is comma. And so that, you know, if you, let's say, let's try something different. Let's say if my delimiter is XYZ, let's say, I'm just going to give some, let's say if it takes it. Now let's check the AR1 text file. What is there? Okay, it's ignoring that. I think maybe something. So probably it's not using delimiter anymore. Maybe, so this was just a way to distinguish between two members, two elements. If I think it might have a default delimiter also. Let's, yeah, so it's saying, okay, by default, it is space. It's space. So if I don't use delimiter, let's see what happens. See, good thing is when you get this, you know, your goal is to kind of, you know, remove things and try to break the code and then see why it doesn't work so that you can understand it better. If I use this, still, I don't get, okay, there's a space here. There's a space here, there's a space here, there's a space here. What if I think it's ignoring the delimiter completely. Yeah. So maybe something the NumPy team did. I think it's still, yeah, it's only using space. It's not using comma. So the only special maybe, and I don't think so, but let's try. There's no harm in checking it out. So let's check it. Still no, I don't know what. So it seems like something in the code is, you know, not taking delimiter. You know, remember, NumPy is also a code. It breaks from time to time as people update it. Yes, right? So that is, all right. So is everybody comfortable with NumPy arrays and how to work with NumPy arrays? And of course, don't try to memorize, but have an idea. As you try it more, you'll become better and better with this. So Pranjali's question is, what is the difference between arrays and lists? That's a good question. I believe the difference is, I think arrays are of fixed size probably, and maybe only one type of data. And list can have, you can change the list size and it can have different data type in it. Pranjali. But probably, you know, I'll check what other differences are between list and array. But usually we work with NumPy arrays in machine learning. Why? Because we can do fast operations. Yeah. So right. So you know. All right. Question from Shiva. Shiva, will this session be shared with us? You mean the recording, Shiva? And the notebook? Yeah. Yes. Definitely. Definitely. Yes. You will get the notebook, and it will be. You know, of course, the session is getting recorded, so it will be, I believe it will be shared. Yeah. All right. So, you know, and that's why in the beginning I said, you know, if somebody is joining a new, or, you know, it's always good to kind of, you know, revise. You know, you don't get, you know, you learn a few things, but if you don't revise, you know, you lose that information that you gain. You know, just like in learning anything. You know, we have to practice. So that's the key. All right. So that's all the time we had for today. Any more questions on this? So next week, what we're going to do is we will learn about another important library which works very well with two-dimensional data called pandas. So you will be using a lot of pandas in machine learning. So we'll get familiar with pandas. Huh? Now, Gautam's question, sorry, can we accept directly data to NumPy array as user input? Not necessarily, probably, but we can write a program, Gautam, for that. Just like, you can put it in list, you can put it in NumPy array. Maybe we have to write the code, but probably not directly, Maybe you can give a file name and we can load the file. So that's one way. So that's now question from Mukesh is how to create 3D array. So Mukesh, let me show you. So we did create 3D array. It looked ugly, but we did. Let me show you where was the 3D array. Or let me, we created a 3D array of number ones. Where is that one? It was a big array. Yes, this one. So Mukesh, do you see this? We have 5 rows, 6 columns, and at each point depth of 2, 3 dimensions. First dimension value is 5, second dimension value is 6, third dimension value is 2. So you see this array, it looks a little hard to visualize. See, 3D is hard to visualize unless it's in a picture form. For humans, it's hard to visualize 3D data. But this is 3-dimensional array. So I said, if you see 3 square brackets in the beginning, that's 3-dimensional. Yeah. All right. So thank you, folks. Thank you very much. And please, Sachi has shared a review link. Please provide your feedback. It's very important. Appreciate feedback from all of you, and that'll be very helpful.
Yes. Thank you so much, sir.
Thank you. And we will continue next week. Thank you, folks.
Yes. So am I audible, sir?
Yes. Sachi, go ahead, please. Go ahead.
Yeah. So I can see a lot of thank you messages also. Thanks everyone for especially being there and all throughout. So I would appreciate everybody putting the same messages on Trustpilot because
Trustpilot.
Yeah,
yes.
helps us in the messages reaching us, sir, and everyone, and also it helps us in making the community stronger. The feedback will also help us improve the sessions. So I would just play Jay's one of the messages.
Yeah, thank you.
I'm sure the community also likes it. So just before everybody goes, 2 things. One is I've shut off the chat so you guys can talk. I would really appreciate it if you can actually go to Trustpilot. All reviews are equal, but some reviews are more equal than the others. Just give us 5-star, right? Nothing less. I'll tell you why, because I'll be shameless about it. People, newer members of the community who come in, the first thing, even if you're ordering biryani or go to Zomato, you look at reviews and they come in. So if you want to attract quality people, more higher pedigree, they're going to read the reviews, make it thoughtful, make it this thing. Let's take about 3-4 minutes about that. And I'm going to be, sorry, I'm being a little, hard on that, but we need to raise to like a lot of reviews, quantity first, and then we'll worry about the quality. And just summarize the top 3 learnings. So I repeat, 5-star rating with top 3 learnings of what you've done right now, good or bad, hopefully more good. And meanwhile, once you're done, type done in the chat box, guys. I need at least all 47 done.
Yes. So I will request everyone to just take a little bit more time, 1 or 2 minutes, and put up the review for this current session. Yes, Rajeev, so you can safely drop the call now. We'll just finish the reviews.
All right. Okay. Thank you, everyone. Thank you.
Thank you so much. Yeah. So once you're done with the review, you know the drill. Just go ahead and put up the done. We will have a count of that. Thank you, Ananta Krishna, for the review. Yeah, the session, you'll be able to see the notebook link and the earlier session notebook also on on the inner circle, and also we'll upload the material also, the notebook and everything. Probably by tomorrow. by noon tomorrow. I'll just check with you. Yes, thank you for staying along and for reviewing. Thank you. Thank you, Sairam, for the review of the current session. Yeah, the recording will be also available on Teachable.